Turn it off. All right. First, I apologize. I messed up the schedule. I thought my class was scheduled 1 p.m. or something like that, 1:10 p.m. For some reason, I put it in my calendar. And so I totally missed it. I'm sorry about that. I will find a way to catch up in terms of a curriculum. Okay. So I'm going to kind of go through the syllabus, which is already announced in the Canvas, but I will directly go to the grading policy. I think that is something which I would like to use this as a starting point for you to kind of understand how we're going to run for this particular quarter. So this is the top 4 line is essentially how we're going to calculate your grade, the 100%. The first one is programming assignment, which is 40%, which is the homework assignment number 1 is already out. And each of them is 10%. So totally, you're going to have 4 programming assignments this quarter. And I'm going to request something called participation credit. Participation basically saying that, well, we're going to have some activity. Student will be work together in small team, like 2 or 3 students. So at least one of you should actually bring your laptop. I will talk about the laptop situation a little bit later when we talk about homework assignment number 1. So you can run some program or modify some small program and to interact with my server, which is my computer over here. And then if you actually submit, then you will count as a 1 participation credit. So there are at least 5 times I'm going to do that. I hope I can do 10 times through the quarter, 10 times. But for each of the participation credit, meaning that, for example, we're not doing that today, but assuming I'm doing that today, for all of you submit your ID or student ID over here, and in that case, we'll count it as 1, as 2%. So essentially, if you participate 5 of those, whatever, how many sessions that we will have this quarter, you will get that 10%. It's not about the correctness, it's about whether you participate in a small programming experiment in class. Okay, so there are 5 times, that's the 10%, the second one, participation credit. Homework 40%, which is full programming assignment. And then the midterm is going to be 20%. And the final project is going to be 30%. Okay, so midterm, I attach the sample midterm in the syllabus, and I will probably give you more sample midterm. For this midterm, my plan is not finalized because of the concern of ChatGPT and those kind of technology. I'm actually thinking that midterm is going to be closed book, closed internet. All right, so you can probably I will give you some like a boundary about what kind of question I'm going to ask, but that's going to happen probably toward the middle of May. Okay, in the middle of the May, we're going to have the midterm. And we will not have a final exam, but we'll have a final team project. So each team is going to be 2 to 3 students. And the final project is based on the program I already provided in the GitHub master directory. Okay, so let me just show you very quickly about what this program is doing so you can see that. So essentially what midterm is doing is midterm will ask you to look at a system that's already built with certain feature, which I will tell you what kind of system it is. It's essentially the combination of a social media system with a search engine. So essentially you can think about it's a very minimal version of what Facebook and Google are doing. And the thing is that it has limited feature. Of course, it's a simple. If you look at that directory, it's only, I don't know how many lines of code. It's not big. So essentially, this saying that, okay, whatever those companies are doing, they're not that complicated anyway. But what I will challenge you to do the final project, you can actually start thinking even today about, based on that master directory, you would say, hey, what kind of extra feature you would like to include it, okay, in that. For example, in that feature, in that master program, the search engine is totally based on keyword. So you can type in the keyword, you can search for a certain kind of content you would like to search. But you can enhance it. What do you mean extension? You can enhance such that you search based on GPS location. I mean, that's a feature, right? That's a feature, not necessarily the feature that's Facebook or Google. They both have this feature, by the way. But the directory I provide, they don't have that feature. So I want you to decide as a team to decide what feature you like to extend from that. And so the final project will be, you have a real implementation. The first thing you need to tell me is that why you think in terms of social media assistant and the search engine, this feature is important. So I'm asking you why you want to do this, why this feature is critical. That's part of the grading. It's not just, hey, I pick the location as a feature and that's it. I implement that. That's actually, you're going to get some average score. But in order for you to get a good score, you have to justify why you want to choose that feature. So object-oriented programming, by the way, is important. Is a little bit different from ecs36b, which over there, you just given a problem and you try to solve it. I mean, the harder part about object-oriented programming, which we will cover the whole quarter, is not just about the syntax and semantics about the language itself, but also how you can apply this semantic to solve some problem. So in that case, you have to actually justify why, in some sense, or why do you do this program? Remember that. Okay, so in the final, probably we're going to do the final week or the last week of the instruction that you will schedule appointment with me, 2 or 3 students. The first thing you're going to tell me is why this feature is important. And then you basically show me the code, how you actually implement that feature. So I'm going to show you a very quick demo about what's currently in the code in the GitHub directory, which you all can download. Okay, by the way, this is a directory. Let me do a make a clean. If you're not familiar with make is a tool that you need to learn, okay, which is the first homework assignment. I actually want to do that. So you can see I have a bunch of files over here. By the way, most of this is a concept called class. So object-oriented program is, well, we need to create a bunch of objects, and those objects are being created based on some template specification, which is we call class. So I compile a bunch of programs just to let you know what program I create. 3 programs based on the make file. The first program is called, let me see, where's the name? Okay, the first program is called ecs36b server. So I have a program called server. And the second program is called ecs36b update. The third program is called ecs36b search. So I create 3 programs. One is called on the server side, which you can think about, that's probably Google or Facebook. And the other 2 programs, update, for example, you click a like on a social media post, and you should update that particular like to the content. So that's what that ecs36b update is doing. And ecs36b search is providing the keyword, and it will basically pull out whatever content that has been already updated earlier on the server. So that's the 3 programs. I'm going to show you a very quick demo. This is the client, I'm already here. So this is the same directory. So I go to the client directory. Okay, so I'm going to have a social, remember I said the social media. So here in the social media, in the Facebook, if somebody posts something and somebody leave comments, and somebody click a like, which we call reaction. So let's actually take a look at, here's a post I'm going to update to the server. If you take a look at this post, okay, they have a bunch of things. By the way, the representation I'm using here is called JSON representation. So JSON is an intermediate representation about an object in a readable format. So that's essentially what all the major companies such as Google, Facebook, they use JSON to handle all the social media assistant or search result. Everything is based on JSON. So by the way, if this is the first time you hear about the name JSON or saw this notation, don't worry. I will make sure, it's my job to make sure by the end of the quarter, these things will be marinate into your heart, okay? So the first thing is action. You don't have to worry about action. Okay, here is that particular post. You have a few comments, but I want to show you the message first. Okay, here's a message. It's a post. I post something, say coffee is great. Okay, that's the message. Okay, and then you can see that based on this particular message, people are start clicking like, right? Reaction, for example, I have a one reaction to that is by somebody called Tiny Boba. I mean, I have some student decide to use this avatar name. So we try to not use your student ID or whatever real ID. In this project, we all use fake ID. Okay, that's why we have somebody named Tiny Boba. And then the creation time, I kind of hide it. Okay, means that it was the type and then a bunch of other things. And it was sent to a particular avatar. And then with this, you have a comments. You can see over here, I have a bunch of history. I should probably skip the history. I have a bunch of comments. So those comments, you can see that there was a one comment, and this is a Tiny Boba who left a comment, and the message is some kind of content he left. And also there was some kind of reaction that you can provide. So I just wanted to let you know, this is just an example, the very simple example. I want to show you a little bit more complicated example. No, I get to the wrong part. Sorry, I have to go to a different directory. It should be, do I have S20? Wait a minute, it's under program. And then I have ecs36b s2024. Yeah, this is the right one. Okay, so I'm going to climb. Okay, that's the same thing, but it's a little bit different. But I actually store some JSON sample. Okay, so you can see that I have some JSON sample. I have some update JSON because they have a different people adding more reaction, adding more stuff that's actually being included over there. But the base is here. This is the base I want to show you. More / JSON sample base 1. Okay, you can see that this is a little bit less readable, but it's essentially a pack about all the information in one line. It's just a different representation, but the content is exactly the same. You can see that there was, let me see. Okay, can you see where's the message? Let me see if I can see the message. This is the comment. I see the comments here. I'm looking for a message. It must be somewhere. Anyway, don't worry. All right, I'm going to run the program anyway. So I have the server side. So you can see that the server, if you look at the post, see how many posts, there was nothing there. So I'm going to run this. And also you look at the O key, the search keyword, there's nothing. This is a server directory. So I'm going to run the program I just create called ecs36b server. Okay, I'm actually starting the server. And now I'm going back to client. I'm going to run ecs36b. Let me do update. And then I'm going to put this particular post. Okay, I'm going to update this particular post to the server. So here's a client server concept. And so after I put it, it's over there. And now let's look at the server. In the server side, you see that I'm actually receiving somebody did an update on a particular post. So essentially here we're doing, because have a blank directory. So this is a new post coming in. But if you have an existing post with the same post ID, the master program will merge. For example, you include new reaction, it will merge into the new post. That's the functionality of that program. We will, by the way, we'll go into this program step by step so you understand how it can be done. Okay, so I'm going to kill this program, just to let you know. And now if you look at the post directory, now you see that there is a new post being saved, stored there. So it has been permanent. That's actually can be used there. And then you look at the O key. I thought I have, okay, this program, this post, I probably didn't put any keywords. So now the keyword was not. But later I will show you how you can use the keyword feature such that the post, what's the keyword to search to this post will be stored in the O key directory. So later when you do search, you will be able to find that out. Okay, so I will show you a more extended demonstration and the source code, how they are related for the simple program I just showed you. But today I just want to give you a concept about what kind of project you will be doing. So this is the code has been given to you. You need to decide, of course, you need to form a team at some point. And your team is going to decide what kind of feature that you think that this program, it doesn't have right now. So you want to actually include it. That's going to be your final project. Okay, so now let's actually go back to this, how I'm going to do the grading. Is essentially 40% for programming assignment, 10% for participation, and 20% in the middle of May. And then there is a final team project demonstration that's going to happen in the finals week, or I believe some of you will be doing it in the finals week, but some of you will be doing probably the week before if you're ready to do that. Okay. I just want to tell you that last quarter, or it's fourth quarter, there was some mistake. There was some misunderstanding. Is that Canvas provide you about the grading, provide you saying that, hey, what's your grade, things like that. It doesn't have any idea about that distribution, about how we're going to handle it. For example, when I have a more homework assignment, I sometimes will drop the lowest grade. And that is totally misleading, the data that's shown in Canvas. So if you look at the individual grade component in Canvas, it is okay. But if you look at the final grade about what you're going to get, that's actually, don't trust that. If you have any concern, any question, you can ask me. Okay. All right. So now I can tell you a little bit about the rest of the syllabus. Prerequisite. This is the official prerequisite from the computer science department. I'm assuming you have either taken ecs36a before, which means that you have some knowledge about Unix operating system and C. Or you have taken courses, which is, for example, some of you are a transfer student that you have learned some of the subject from other sources. Either case is fine. However, if you have never got a chance to learn C and Unix, I just want to warn you, you can stay in the class. I will try to give you some help about how you can do self-study. But the thing is, you need to work really hard for the first 2 weeks because the first homework assignment has been released. Let me actually go over the first homework assignment now. Okay, the first homework assignment, if you already done the part one, so what is part one? Part one is essentially make sure that you have access to a Unix environment that you can use that for the rest of the quarter. If you already done part one, if you already know C programming, then I would say part two is going to be very simple. You could have done it in about 10 minutes. But don't wait until the last 2 minutes, last 10 minutes before the deadline, okay? Please don't do that. I'm just don't trust me on that as well, okay? But this is really give you some time for you to catch up. Make sure that everybody in this class that we have a reliable Unix environment. I mean, it's already given to us by CSIF. If you use CSIF, that you already have that environment, which you just need to use a program called SSH, Secure Shell, to remotely log in to CSIF facility. You can work on that. But here I said, it's highly recommended that you try to do that kind of environment on your own computer. So I'm assuming all of us who have a laptop computer, you're either running a Mac OS, or you're running Windows. I don't believe too many of us having a desktop laptop which is running Linux from the hardware. So if you have a Mac, then essentially those part one should already given to you. So the homework assignment number one is just make sure that you actually verify that you actually have that environment if you have a MacBook. However, if you have a Windows, you cannot develop homework, not just this homework, for the rest of the quarter directly. You have to install another program called WSL. WSL stands for Windows Subsystem for Linux. It's a free software developed by Microsoft. It's called WSL. And when you install WSL, then you can actually install a version of Linux. Any version, I will recommend you use Ubuntu, a stable version of Ubuntu, then you will have that. And the instruction about how to do WSL is actually provided with the syllabus as well, okay? So that's homework assignment one I want you to do. But in this process, not only I want to make sure you have a stable environment, but also for doing homework assignment number one, I want to make sure that you at least somewhat familiar with the tool I mentioned in the process. This tool, except G++, okay, G++, you should know shell from 36A. All right, by the way, I could be wrong about this. When I taught EC36A, this is a must for that course. You will learn shell, you should know bake, you might or might not know tar, but you should know one of the editor. Okay, using terminal means that using terminal usually is a VI or Emacs, those kind of tools. So in this process, I want you to make sure you learn those. I will provide you a link. You can see I already provide some link about how to do the basic Linux command, how to do make. I will spend some time make because my experience is that usually you don't learn enough about make file from the first course, ecs36b. So it's good for us to refresh some of the key concept about make, and also compiler, which is a G++. But in ecs36a, you were using GCC. GCC and G++, they are compatible, at least backward compatible. So which means that any program that's compilable by GCC should be compiled without any problem with G++, but not vice versa. So you can use G++ to compile any program, C or C++, but you can use GCC to compile only the C program. So now we're doing a transition between, from GCC to G++, okay? Any question? I have provided a lot of information. Any question? Let me just ask you, just to verify, make sure that you're not completely lost at this point. So how many of you already learned about like a GCC or makefile or editor? Okay, good. Most of you have done that. So that's good. Okay, so G++ is very similar to GCC, except you need to provide the what I call the version number, because G++ has so many different versions, and you have to specify which version you will be using. That's the major difference. The rest, the usage between GCC and G++ should be the same. Okay. Yes, please.
Will we know which version?
Yes. Typically, for this quarter, we will, I think using C++ 14 will be good enough. So if you look at the makefile in the master directory, you can see here, I set CC, which is, by the way, this is the way I write makefile. This is called macro. I declare a command called capital CC. And what is a capital CC? Is G++ minus STD equal to C++ 14. So C++ 14 was the version of C++ compiler that was actually developed, released in 2014. Okay, I think that's 2014. Okay, so we're going to use this line. So usually I provide a makefile. So with 2014, I think you can use C++ 17 as well, or C++ 11. C++ 11, 14, 17 should all work. But I realize this is the messy part about C++ versus another language like Python or Java. Python and Java, I better not say anything about Python. I realize that also have a version issue. But in other language, they are not so sensitive to the version of compiler you're using. I mean, I should use the Python as a good example. So if you're using Python, a particular version, if you run on Mac or you run on Windows, the result should be the same. Result should be the same means that this version should either work for both or work for none of them, okay, for the same version. But G++ is interesting, at least my experience, is that I can run the same program really well for C++ 14 on Mac. But when I switch to Windows with WSL, for the same program, I will use C++ 17. So C++ sometimes they have this kind of system compatibility issue. That's why it's a harder language. I usually, if you taking my course, you will have heard me say that C++ is a much harder language because it needs to deal with this kind of system low-level detail sometimes create because the operating system is different. The Mac OS is based on a flavor of Unix operating system called FreeBSD, while the WSL is based on the flavor of Linux. So there's some kind of difference over there. So C++ programmer, you always have to worry about this kind of variation, while the Python compiler, as long as you decide you're go with Python 2 point something or 3 point something, you're done. Okay. Any other question? So to conclude, my answer to your question for this class, you'll probably be able to use C+14. But if that doesn't work, just change to 17. It should work. Okay, you're welcome. So just so you know, since we're at this topic, I mean, this is probably for some of you, this is the first time you saw something called makefile. So makefile is a configuration file for you to tell the system how to compile and build your program. All right, so you can see that over here, I use CC, right? And over here, you can see that I use that CC rule. For example, I'll compile a program called, let me look for the program I'm going to show you today, which is the GPS. Okay, you can see I have a rule here, GPS, and I want to create the target called GPS.o. By the way, now you actually see 3 different kinds of files, .c file or .cpp file, .h file, and then .o file, which is an object file. It's a binary file. So I want to create a .o file. Let's look at how I did that. I'm actually using a $ capital CC. Remember, capital CC is a macro with a $ and the parentheses. It was replaced by the string I show you, which is the G++ minus STD is equal to C++ 14. So it was a string replacement to replace that $. So it became G++ minus STD equal to C++ 14 minus C, which is the flag, asked them to only do the compiling, not do the linking. And later you will learn what is the difference between compiling and the linking. Okay. And then with some kind of flag you need to provide in the compiler. And finally, it's a program I try to generate that target, which is the GPS.cpp. Is the program that we're going to talk about that today. Okay. Okay, so I'm very quickly to get through. This is homework assignment number 1. We'll actually talk about that later, if not next lecture, next Tuesday. But just to let you know, the first program will be due April 18, 11:59. Okay, just want to tell you that it's really a program not to spend a lot of time, but most of the time, I want you to make sure that you have an environment and also make sure that you at least know some of the tools, okay, to do. For example, there's 5 files you need to submit. Just show you that what is the 5 file you need to submit. You need to submit a makefile, which I will give you a sample about what the makefile looks like. By the way, I will say this makefile, I will provide it for you. You don't have to write a makefile, but I will give you a valid makefile. If you have a valid Unix environment, you can use that right away. So you don't have to do anything. And the README file, put your email address, student ID. And then this 3 program you need to develop. The one of the program is called homework 1 part 2.cpp, which I will show you a very simple version of that program looks like. And GPS.cpp and GPS.h, they are already included in the master directory. Okay, so you can see that the amount of code you need to write is not so substantial, but you need to integrate and test it whether it works. Okay, so programming is really important. Is you run the program, you know it works. That matters. Okay. All right. Any question? Okay, I'm going to go back to the curriculum. So that's prerequisite. I'm not just, you can read what my instructional goal, and I don't think we have a wait list. Don't worry about that. The content, I will put it under whatever my YouTube channel, like today, after I'm done, I'm going to upload that. I do want to mention we have a, okay, I think I have an office hour later in the curriculum, but the textbook is over there. This is the textbook. If you are a UC Davis student, you should have a UC Davis account. Then you can access to library VPN. then you can actually download this book for free. Okay, this is the book that you can download. For the first part of the class, we're going to cover chapter 11, 12, 13 to 14, those 4 chapters. Those are the core chapter of object-oriented programming. You ask, what's before chapter 11? So in my opinion, the book before chapter 11 is really talking about the C programming. Okay, and starting from chapter 11 is really going to C++. So I use the chapter 2 to chapter 10 as a reference because some of you want to catch up some of the concept in C programming. By the way, C++ programmer, you still need to use some of the C concept. You can go back to actually find that out, or you can ask me. I'll be happy to tell you that. But the major focus about object-oriented programming starting with chapter 11. So we are, as today, we're into chapter 11 of the textbook over there. You can download, okay? All right, this is the requirement and topic I'm going to skip. Okay, so here is my contact information and my office hour. My office hour is going to be 1:30 to 2:30 Tuesday and Friday at 2357 Academic Search. Okay, so that is in fact my lab. So it's pretty big. We can have like 10 to 15 students simultaneously sit there with your laptop. So typically, if I have some topic which is really of a general interest, then I will record it and talk to everybody via Zoom. But if you want me to help you with the debugging, I mean, I will try to use the discussion session for debugging as well, for debugging, for homework, for a project. And also you can, if you bring your laptop over there, typically the way I do is I let a few group of students, they kind of helping each other. I kind of round robin and go through each of the group and try to help them to resolve the issue. I feel that one of the good use about my time is actually helping to debug because I have more experience writing C and C++ program. And sometimes I can smell the bug very quickly, quicker than you, most of the case. So you're very much encouraged to come to my office hour to actually to show me something. I can tell you where's the problem and what you learn from that process. Okay. Okay, and let me see. Okay, that's some of the Unix tool. The first 2 weeks, I said there was a few tools that you should familiar with this. I put it there over here. And then you can see that from this page, I talk about installation of WSL. This is only if you have a laptop you intend to use this quarter for ecs36b as running Windows operating system. Okay, and WSL is an interesting project. It has some hassle. You need to spend time. Sometime I will also in my office hour help student or discussion hour to figure out how to configure it correctly because different Windows system, they have a little bit different in terms of Windows 10 and Windows 11. So sometimes we have to try it. And I say I recommend you Ubuntu 18.04 if you're going to use WSL. And you can see that this part is the sample. I think this is a sample midterm I have over here for you to actually take a look at that. Okay. All right. So I quickly go through the syllabus, homework 1, and also a little bit about Makefile. Any question at this moment before I start to talk about object-oriented programming? Yes, please. This week, yeah. So this Friday, you can actually come to my office out, which is tomorrow. Yes, please. Canvas. Okay. So yeah, Canvas, I already created the entry. You just upload the file. Yeah.
What would be great? I won't think homework won't be great.
Homework 1 is very simple. Homework 1 is essentially we want to see, I will announce the policy. Usually we announce the policy. Formula one is number one, if you're correct, you submit those five file and your program running and you get the correct distance. The Formula one is calculating the distance between two GPS location. And so if you calculate the distance correctly, you get all 10%. Yeah. But if you miss some of that, say your program doesn't compile, that you only get partial credit. Any other question? Yes. Yes. Yes, you can submit anytime. However, we won't be able to, unless the TA has a way to do automated grading. And we cannot give you the feedback, and then we basically will grade it after the deadline pass. Okay. Okay, any other question? Okay, let's now talk about our Is there any way I can turn off the light? Not too much? Okay. So so this is the picture. What do you see from the picture? What do you see from this view picture? Yes. A fridge. What other things do you see? A lot of object. What kind of object? Everyday objects. Yeah, we have a food, right? A lot of food items, a lot of people, and fridge, right? Fridge, I represent storage, right? So there was a one thing you probably didn't see. There was a beer. Okay, there was a food and there was a beer. Okay, so we're talking about alcohol. All right. So all right. Let me actually tell you why I'm showing you this, because this is the project about whether it's ethical for you to make a recommendation like a coupon when you visit a store like Nugget or Safeway, right? When you actually walk by like this person and you're near the product, you can reach, it's really tempting, okay, at least for me. I know none of you have this problem. So when I look at this, I have this problem. I want to tempting to say, hey, this is so nice. I can enjoy the rest of the evening with a box of this product. Okay, so it's ethical for the store, say Nugget, to suddenly send me a 30% discount. If I got a 30% discount and I saw a product I like, then I'm going to there to grab it, right? So that's kind of the system is trying to mandate what kind of things we can consume. So this is essentially a real life system we're dealing with. And as what's your name in the back? You were here before, right? I remember I saw you. What? 32A. 32A. Oh, I see. Okay. Your face looks familiar to me. Yeah. But the thing is that each of this, how do I actually model is related to the object. So let me tell you a few things I need to worry about for me to decide whether I can release the coupon to the person. So first, I need to access to that person's medical record. I want to make sure this person is not addicted to alcohol. If somebody is addicted to alcohol, this coupon shouldn't be released, right? Or I want to see how they're going to use this product, because eventually this box of beer is going to put it in the smart fridge in this person. And then the smart fridge, by the way, the next generation definitely have this feature because I built a prototype for that. I have a camera, I have a sensor to sensing your social activity at home. I know like whether you have certain kind of behavior, which I think is not so ethical if you have too many boxes of beer in your fridge. Okay, so this is a real life scenario we need to provide. And therefore, we need to actually model every piece of information, including the product, including the person, including the health record, including the fridge, including the camera, including the social interaction that happens there. So there's lots of objects. And if you think about this world, this is the real world we're talking about. I took a few pictures. But the thing is that when I convert the real world to the cyber world, so what is the difference between the real world and the cyber world? Cyber world is using some kind of digital representation, which in this quarter you're going to learn called object-oriented paradigm, to represent in the real world. So I want to solve a real world problem. What should I do? I actually want to solve the problem to deal with those C++ object or Python object or JSON object in the transformation of the real world into the cyber world. If I can solve that problem in the cyber world, I solve the real problem. I mean, you probably can imagine pretty much all the IT application is following this paradigm. So here, why is object-oriented programming important? Because it provides us a way to model information that matters in the real world, but then we kind of convert it to a way which we know is a structure. We know how to deal with that with a lot of other objects, and then I can compute. So you can think about object programming. So what you learn is not just a programming language, it's a tool, it's a process for you to represent the real world in the virtual world. Okay, so that's how I hope you will learn this quarter. So I'm going to go through there's two kind of objectives I try to accomplish in this quarter. Of course, there's object-oriented programming language. You can think about this programming. It's like a linguistic perspective about the language. You want to understand the syntax. You understand the semantics about how you should use this language. That's the programming. Let's talk about the linguistic perspective of that language. But the other perspective is usually we talk about object-oriented thinking. Object-oriented thinking means that, wait a minute, I know what's the syntax of the program such that G++ compiler can help me to compile. But a more interesting question is that, well, what kind of objects I need to have in my program? So you can think about, well, why it's called object-oriented? Because we have to have a lot of objects. And for example, in the previous picture I show you, I might have an object representing the storage, which is the smart fridge. I have to have an object called a person, and I have to have an object called medical record. I have to have the object called a product or a beer. And I have a bunch of this information. So I have to have all of them. If I have all of them, then I just need to worry about how to stitching them together into a single system so I can solve the problem. But in order to do that, we realize why object-oriented thinking is important is in order for you to use object-oriented programming language, such as C++, to solve a real-world problem, it's not hard to stitch things together if you already design a bunch of classes over there. If you already design a bunch of what we call object or classes. Let me go back to my master directory. By the way, you should start playing around with this if you're interested. You can see that I have a bunch of, let me make it a little bit bigger. I have a bunch of classes already. Let me just tell you, for example, I have something called thing. I have something called thing. The thing can be anything. Thing can be a fridge. Thing can be a bottle of beer, thing can be anything you want. So I already have a thing, and I have a tag. I have something I call post, I have a person, and I have a reaction, I have a GPS location, and I will tell you what's locatable, what's labeled, I have a time. You see that I have a bunch of class. I'm actually using the word class and object interchangeably at this point, but later I will tell you exactly what's the difference between the class and the object. You can see that I provide a bunch of class I already defined. So in object-oriented programming, it's a little bit different from the ecs36b, which you actually think about, okay, how do I write the whole piece of program to work? In object-oriented programming, it's always you go into a directory, looks like this. It's like you walk into a supermarket and you see, okay, my scenario, what kind of things I need, I just pick it up. I pick a few things, and then I do some kind of extension, and the major extension mechanism in object-oriented programming is called inheritance. So what is an inheritance? Inheritance say, hey, I have something called thing, but thing is too generic. I want to be a refrigerator, so maybe I will extend from thing to create another class called appliance. And then another appliance extend, I become the refrigerator. And from the refrigerator, I have a smart fridge. So you can actually extend based on this. So object-oriented programming is always in your mind what kind of object you want to create. And then you go into a store and then decide what is the best fit. And then you start to bridge the gap to what you really want. And once you've done that process, then the rest is just a faithful representation about what happened to the real world. If you think about that, if you have all the fridge, whatever, you just base your understanding about what real world is operating, and then you just put these things together. Okay. All right, now let's continue. So there's a few object-oriented principles that we're going to cover. This is the topic we're going to cover in chapter 11 to 14. This including what we call data abstraction, holomorphism, inheritance, and the encapsulation. Each of them is providing some perspective in that process to help you to make things right. And the first thing we're going to talk about is data abstraction, which is the most important thing, is the concept called class. Okay, so now I'm going to really talk about your first program, which I want to use. Let me see, should I go here? Yeah, this is good. I'm going to do, you see I have this program, I'm going to put it, upload it to the GitHub. This is called a test program that's represent today's date. Okay, so every time I write a program in class, that particular lecture, you will see the timestamp for that, and that program you will remember that what we cover. So this is the program, your first program I'm going to show you. So by the way, this program, if you look at homework assignment number 1, homework assignment number 1, not this, not you. Where's my homework assignment number 1? Here. Remember, homework assignment number 1 has 5 files. This program is equivalent to hw1p2.cpp, which is the driver about the whole program. And then it's going to use one class definition, which is GPS CPP and GPS.h. Okay, so I'm going to start explaining this file first. Let me first compile this program before I run this program, before I explain the detail about this program. So I'm not going to use a makefile, so I would use g++ minus std is equal to c++ 14. And then I'm going to compile this program, 0404, this. If I compile this program, it basically give me some error message. Can you try to read this? What kind of error message that this compiler is telling me? Let me make it bigger. What kind of error message I saw this part? What does this part tell us? Ready? By the way, there is no standard answer, so try your best. Provide a guess. It won't hurt. It's a compiler error, but what kind of compiler error we got here? Yeah. It's not with make. I'm not using make. It's actually a linking error. So by the way, I just want to tell you that this is something which it still amazes me about how slow we progress in terms of providing error message in program like G++ and GCC without very user-friendly. So if you don't know what the error message is telling you, that's normal. On the other hand, most students, they actually look at this message, it's just panic, okay? Just wanted to be honest, I mean, this is actually considered pretty good. They only have about 20 lines. And sometimes you're just missing one character, you actually got about pages of error message from a G++ compiler. So the thing is that I know that that's actually psychologically, even myself at one point. By the way, the first C program I wrote is in 1983. The first C++ program I wrote is 1987. So I've been writing programs, C for 40 years. I can tell you that this horrible style hasn't changed much at all, okay? So, but the thing is, the positive message over here I want to tell you is that don't be afraid, okay? Don't be discouraged. You have to read through it to identify exactly what's your problem. And then that will solve your problem. So let me tell you that the difference between you and me, the true difference between you and me is that I will not be discouraged when I saw this, and then I will look through it, find an error. And for many of you, you probably just, I mean, that's the only difference, to be honest. And you can be a professor next quarter, either way, you fix this issue, right? Talk to the department chair, right? So, okay, so if you look at this, you have to look at the keyword. Here's an arrow. You see that? They actually do this better because I was in 1987 or 84. It was black and white, so they cannot even do arrow in red. Okay, so that's a great improvement in our society. I'm really proud of that. Okay, so basically it says arrow said the linker command failed. So it means that it's actually trying to link a program. It was not there. Look at the command line. What did I do? I just compiled this program. And which is a program, but this program using some object. Remember, what's object in programming? I need to snap a few already defined classes, object, and then I will be able to integrate together. And so I need to integrate, I need to link to those. So you can see that it tried to link to a function called GPSDD distance. It's referenced by this program. And it tried to link to GPS, DD, whatever, referenced by this program. So essentially, the program tried to reference to some definition that's in the C++ classes, but I didn't provide. And therefore, it has a linker command error. Okay, that's the error message really tried to say. Okay, and I don't know whether ChatGPT can actually do a better job at this point, but let's not rely on that too much. But let me tell you how to fix it. So you understand the error? The easiest way is just include gps.cpp. Okay, so because I haven't had the class called GPS-CPP. So if I include this, done, no error. So I can actually run this program without any trouble. Okay, so you can see that's just want to tell you that why you have to have GPS.cpp, GPS.h, you have to have the whatever the other driver program, and then you have to compile using both of them together, and then you will be able to compile. Okay, so make sure you know what's the role of that program in the whole process. So now let's actually look at the first program, which is the driver program. I will first look at this program called test004 s2024 CPP. Then I will look at GPS.h and GPS.cpp. That's my hope by the end of class, which we have another 10 minutes, 20 minutes, right? We have another 20 minutes, okay? All right, so the first line is just an include file, okay? This is, if you know C, that's a standard C syntax, meaning that I try to include something that's defined in another file, which in this case is GPS.h. I include that file. And then this is a standard, the beginning of a C or C++ program is the main function. That means the entry point of the program. And then you have this two function called argc, argv, which represent how your program is going to interact with the command shell. In the command shell, you're going to type a few things, and how whatever you type in is going to enter this program is actually through that two parameter, argc and argv, which is, let me just check. How many of you have heard about argc, argv before? Okay, so the rest of you, if you're not familiar with this, that means you might have some small gap, okay, in C programming or Unix, just let me know, okay? All right, so over here, I'm going to do the first line. Okay, by the way, in C++, if you see anything to do with double slash, that means it's just a command line. It's a command line, it's just for you to provide whatever document you want to enhance the understandability about your program, okay? So if it's double slash, you can just neglect, the compiler won't even bother to touch that. Okay, so the first line is really this GPS, this line. Okay, let's look at this line. This is the first word. This is the first time you saw that. The first word says, what is the class? So the class is called GPSDD. It's like a type. How do you define a variable in C? You typically will say integer I, right? You say integer I. So what's int? Int is the type. So when I say class, it's almost equivalent to type. So essentially I said GPSDD, GPS home Woodland. That means GPSDD is equivalent to int, which is the type, which is GPS home Woodland represent the variable name, which represent to I. Okay, so integer I is the same to say, sorry, GPSDD, GPS home Woodland is the same as integer I. And of course, when you do this, you say integer I is equal to 1. What does that mean? It means initialization, right? I initialize a variable to be I. But in starting, I don't know which version of the C++, they introduced a concept called bracket initialization. Means that, well, I have to do bracket initialization because an object represents a more complicated structure. Data structure is not like an int. Int has only one thing. I can put an equal assignment, I can assign. But in the object-oriented, in the object, they have so many things I need to initialize. So I need to have a way to simultaneously initialize multiple values to my object. That's why I developed this paradigm called bracket initialization. So bracket initialization is you put a bracket, and inside the bracket, you put one or more value. And those values will go into the class definition, will match. You will see that when we see the GPS.h and GPS.cpp. So I can initialize this. Okay, so that's one line. This line already pretty significant because if you never heard about object-oriented programming, this is the first time. You have a type, you have an object, and then you have an initialization. Okay, I want to slow down a little bit. Let's go to let me actually first tell okay, I know what to do. I want to use Google Map. Let's go to map. Okay. Oh, that's my wife. Okay. Yeah, we track each other, okay, all the time. All right. She knows where I am. All right. So where I am, I wish I used smartphone. Okay. So we must be somewhere here, right? Ah, Everson Hall. We're actually here, right? Does that make sense? We're here, right? So where's my mouse? Okay, my mouse is there. So in Google Map, if you click on this, you see that when you go to any of the location, you see the first one has two numbers. Okay, has two numbers. In this case, the 38.53807, and the second number is minus 121, whatever, right? So those two numbers, one is represent longitude. Sorry, the first one is latitude. The second one is longitude. So those two numbers is a standard way to represent where we are in GPS format. Okay, so essentially, if you give two double number within certain range, I forgot exactly, minus 192 to plus whatever that range. Okay, I can dig out. I tend to try to not remember those thought of myself. So those two numbers will represent every single location on Earth. All right, so those two numbers. So that's why if you know this, now you go back to the code. Now you realize that I actually initialize with a number which is not exactly the same, but pretty similar. Okay, 38.672 and then minus 121. So those two numbers represent a location. Okay, now I want you to guess. Okay, I want to, so this is nothing to do with programming. Anybody want to guess what address is? Where there was 38.67221.586 minus 121, where that is? Yes. Hey, how can you know that? Yeah, that's almost like my home, right? We spend so much time that's actually Costco. Nice answer. Okay. How did you know that? You actually done this before? What? Oh, you look it up. Okay, great. I like that attitude. Okay. Yeah. I wish I can give you 5% extra credit. Okay. Talk to me privately. Okay. All right. So you can see that it is Woodland. So you can see, okay, it's a location that's actually in Woodland. That's a significant. Now I can use an object which is called GPS. The class is called GPS DD. I use a variable represent that particular location. So that is an object. Object might not be a real object over here, but it could be a concept, an abstract. You can model anything as an object. Okay. All right. So this basically helped me to create an object. Okay. All right. So I kind of provide some kind of annotation over here. You can see that what we did so far is this 3 line. Okay. You have a class name called GPSDB, and you have a variable, and then you have an initialization. Okay, that's it. All right. So now you learn how we can create an object. But now, before I actually went through the rest of the program, now I want to switch back to the class, which is the GPSDB. Which is, I want to first take a look at this GPS.h. So what? I want to go over here, the master version. Okay, I'm going to start talk about, so this class, I put it here, might give you something which is more than needed for your homework assignment number 1, but I include this anyway. So this is a definition of a GPS. So the first thing I want to neglect is you see that I include a core .h, and then I have this part called public core. Okay, so these two parts are what we call inheritance. I'm not going to talk about inheritance today. You don't need to worry about that. So let me do this. Let me get rid of them. You know what? I want to go back to the older version. Maybe this part I didn't do that. Yeah, maybe it's still better to do it this way. Yeah, this part is better because it doesn't have that core GPS. The core, you will see that why I need to have a core, which is represent all the objects such that I can trace a lot of stuff. So you can see here, I have GPS. I will start using this line. I start expand this line because the rest of the stuff is you will learn eventually when you want to make the program to work. So what is a class? A class is very similar to struct. If you're talking about the context about ecs36b that we learned a concept called struct in C programming. The difference between class and the struct is that it follows the same structure, but it introduces some enhanced features such that about how and when that a variable inside a struct can be accessed by which function, which we have a concept called functions over here. So typically when you define a struct, everything inside here, I said typically means that sometimes you can actually have that feature as well. But typically over here, we just define a few variables when you do the struct. But in the class, you have different variable. Some we call a public variable, means everybody else can access. Or you have a private variable, meaning that this variable are protected within the class. I will quantify what do we mean by protected later. And then typically in the class, we have a bunch of function we call the member function. That member function represents a bunch of code that's need to associated with the class, such that when you access a class, you're supposed to use those code. That's called member function. So let me summarize. What is a class? A class is provide a keyword class and the class name, and then in between the parentheses, curly brackets, sorry, not parentheses, curly brackets, you define two kind of things. One is called member, the other one is called member function. Let me actually write it up here. So inside here, you will have a member and you have a member function. Okay, that's a class definition. Okay, so now let's look at how I define the class DD, which I use in the other code. So in the class directory, if you see double slash, don't worry about that. So what I did is I have a private. I have a keyword called private with a colon at the end, and I have another section which says public with a colon. Okay, I'm not going to tell you what's the difference between private and public and also with protected. There are three keywords, could be private, public, protected, until much later. But right now, I just want you to know they exist. That will be good enough for now. But under private, I have two variables. You can see that one is called longitude, one is called latitude. I define two variables. Both of them are double precision floating points. I define the type to be double. Those two numbers represent whatever Google Map is using, those two numbers. And then I have a bunch of function over here. This is called member function. The first two member function is called constructor. So have you noticed that? Okay, let's forget about constructor for a moment. I want to introduce the rest. I will come back because constructor itself is pretty challenged to understand. But I have a two function that the name is the same as the class name, which is a GPSDD. And the thing is that that's called constructor. And then I have a bunch of other function. One of the functions is called get latitude, another function called get longitude, another function called distance, which is the distance you will be, for homework assignment number 1, I'm actually asking you to do distance. By the way, you don't have to write your own code to calculate the distance. The distance code is already in the master directory because the function is already there. Okay. Gratitude, and then there was another function, two function. It started with operator something and then with a minus sign. Okay. Okay. I provide, forget about dump. Dump is something which is you will hear a lot about why I need to have a dump over there. But at this moment, we see a class. The class have a two sessions. One is called private, one is called public. And then you have some variable. I only have a two variable. One is called latitude, one is called longitude. I have a two variable that belong to the class. This is what we call member attribute. Okay, I should probably write it down. This two we call the member attribute. Or member variable. Okay, longitude and latitude. And then we have a bunch of function we call member function. We have one kind of member function called constructor, which means that function name is exactly the same as a class name. And the second kind of member function is just a regular member function, such as get latitude, get longitude, and distance, those three functions. And then I have a kind of function started with the keyword operator. This is called operator overloading, which you will learn, I forgot, chapter 13 or chapter 12, which is another big topic we need to learn. But what you need to understand is the basic structure about a class. Class with a class name, bracket, within bracket, you have some variable, some member function. And with that, you actually be able to define a class. Okay, so this just declare that what is the structure about the class. But for each of the function, you need to provide implementation. You can actually provide the implementation over here. By the way, for example, I can just immediately put the implementation over here with two brackets, just like you write a C program. You can actually do that, but it's usually less readable if the function tend to be big. So typically, we have another program called GPS.cpp, which is provide the member functions true implementation. For example, I said get latitude. Get latitude, you see that this is the get latitude function, and I declare over here, so you have the function get latitude, and then the implementation of the function is just return this to the latitude. Okay, so I define in the GPS.cpp about the function that I declare in GPS.h, which eventually be used. Okay. Any question?
Having like two lines for the constructor with the same name.
Okay, good question. Okay, why we have the constructor is any other question? All right, so let me first answer your question, then I'm going to ask you a few questions. Since you don't ask me any question, I'm going to ask you all the rest of the question. Okay, so the question was, I have, sorry, let me actually get rid of explicit, okay? We don't even need to need explicit at this moment. I have only 1 minute, okay. I have the function called GPSDD. And essentially I have a two function with the same name. Okay, have you ever written a program that you have the same function name, but you have multiple, two different functions with the same function name? Have you ever had that experience? Yes.
Like having two similar functions with like both the same types? Or do you mean like
No, I'm saying that you have two functions in C, for example, in programming in C. These two functions, their function name are exactly the same. Maybe their return type also exactly the same. But they are actually two different functions. The reason I ask this question is called function signature. Well, how do you uniquely decide a function is this function you try to call? So usually we think that the function was uniquely defined by name, which is not true. A function is uniquely defined by both the function name, the return type, and the number of argument, input argument, and their type. So in some way that these two are two different functions. It looks the same name because I sometimes create a refrigerator. I might have a two different way to configure initially to set it up, and I have that. But as we're already almost over time by 1 minute, I just want to tell you one thing. You see that this second function take two double, right? Take two double means that the input argument has two double. So now let's go back to our previous code. This line, you see that this bracket initialization, how many argument we have? Two. They're both double or floating point. So the compiler basically look at this bracket initialization, it's a GPS, and look at how I want to initialize that object called GPS over Woodland. So it will link this particular constructor, which is initialization. When I say constructor, it's really initialization. And we'll link this to this function over here. The second line. This one instead of first one. If I actually do this, if I do this, if I just do this the way I'm modifying now, then it will hook to the first constructor. But if I do it the way I did it earlier, it will connect. Okay, this is an important concept because sometimes we're confusing about exactly which function that's really getting invoked when we actually decide to initialize or call. When you talk about operator overloading, the situation could be really, really complicated as well. That's why C++, by the way, is a good language, but it's actually very difficult to learn. We have a lot of this kind of tedious detail. I want to make sure we spend enough time to understand. Okay, so thank you for your time today. And I will see most of you next Tuesday, but maybe tomorrow.